Hello everybody, today we are going to be talking about bases in our second lesson from this third booklet on chemistry. So bases are the opposite of an acid. They react with acids aggressively, and they are considered sort of the opposite because they act on a different with a different molecular ion. So bases are bitter tasting water soluble substances that feel slippery when dissolved in water. So when they're in an aqueous solution. So you might already feel like you might know might know some examples. If you think about slippery, we're talking about things like soaps. So bases are typically good conductors of electricity, um, just like acids can be. And this is because they release hydroxide ions when they are dissolved in water. So for example, something like sodium hydroxide, NaOH, this is sodium hydroxide. Sodium hydroxide, when it reacts with water and it gets dissolved, and you can actually buy this on the counter as a solid, at least in the chemical counter that is, it breaks apart, dissolving in water as sodium ions and hydroxide ions. And these hydroxide ions are very special because there are lots and lots of different chemicals that react with hydroxide. And so this makes bases a very reactive material. Any of the materials that produce hydroxide, they will be reactive, and particularly they are reactive with hydrogen or protons. So so maybe I'm going to switch colors here just one second. So hydroxide ions are particularly reactive. So these are very reactive ions, especially with H plus. So now the trick is that H plus doesn't have to be in the solution yet. Hydroxide ions can even rip the hydrogens off of other chemicals, and that causes all sorts of problems. And it is one of the ways that hydroxides, how bases can break down chemicals. So like dirt, or like the coating on a virus, for example. So when we wash our hands with soap, and if we had coronavirus on our hands, then the virus shell is actually sensitive to this hydroxide. The hydroxide attacks the viral shell, tearing the hydrogens off of it, and then that breaks down the material, and the material breaks down, and the viral DNA is exposed. That DNA gets consumed very rapidly by these hydroxides. So that's why we were washing our hands so much during the pandemic. So some bases do not release hydroxide, but instead make hydroxide from water. That's another way they can do it. And that's another reason why not all bases end in OH. So we will have to keep track. Not all bases can directly release it, but they might indirectly cause OH to arrive in the solution. But that's probably something we'll deal with a little bit more in grade 11 chemistry. Bases are described as alkaline. So you might be familiar with some alkaline products like alkaline batteries. These are batteries that have basic components to them. So alkaline is described by a statement that maybe doesn't make a lot of sense yet, but it's going to make a lot of sense by the end of our unit here, and that's any solution with a pH over 7 is considered an alkaline solution. Is considered alkaline. And this is typically the result of adding certain types of salts and things. So we will discuss how basic is defined by this same definition in a second. Bases are corrosive. They can react with proteins to break them down. There are drain cleaners that are considered basic. They destroy hair and hair that plugs your drain. So that's why you're buying that Drano stuff or any of those drain cleaners. They're really strong bases, and they will attack the proteins in those hairs, breaking them down. They can react with proteins like the protein shell, like protein shell of viruses. viruses. These products can destroy proteins in your eyes as well, so that's why they're also very dangerous. Drain cleaners and other products contain NaOH, which is a very common base. A base is a chemical opposite, so it's a chemical opposite of an acid. Where an acid adds hydrogen ions, a base steals them. Essentially, every chemical that is dissolved in water is either an acid or a base. So pretty much every chemical that you add to water, with the exception of things like things that don't, exception of non-ionic compounds. So essentially every ionic compound that's dissolved typically will increase the amount of protons, which are the acid unit, or the amount of hydroxide. So if it adds H plus, then we say that it is an acid. If it adds OH minus, then we say that it is a base. I almost wrote base. Okay, so here's some examples of some of these bases. So all the bases have formula names. They have names. You can see the name is pretty similar, except for these last two. They typically end in hydroxide to indicate that they have that hydroxide unit with them. And then they have a formula, and if they are a hydroxide, they typically have a formula that includes that OH. So an OH is a hydroxide. OH minus, this is hydroxide. We didn't do anything to do with polyatomics this year, so you have to learn them this way. So sodium hydroxide is used as a cleaner. It is also in something called caustic soda. So soda is pretty common. Soda refers to that sodium. It's found even in soap. Calcium hydroxide is used in dentistry. And potassium hydroxide is also called potash. And so this is a product of potassium that we used to use, and it's used in fertilizer. So potassium hydroxide is interesting because we had talked about other fertilizers that use acid, and different types of plant organisms have different dependencies on either potash or on acidic compounds. So sometimes we add phosphates to to your soil to make the water more acidic, or might add nitrates to make the soil more acidic. And that will help some plants grow really well, and then other plants will grow better in a basic environment, so we might add some potash. These are also considered types of lye. So these are some of the old names, types of lye, or common names of these chemicals. Aluminum hydroxide is an antacid, so is sometimes if you have things, I don't believe it's in Tums. I believe Tums has a calcium hydroxide or something. But sometimes, maybe it's Tums, they have aluminum hydroxide in them. So check your antacid cabinet and see if that's what you have. Ammonium hydroxide is a very common cleaner that we have. I know I have it in my basement. Cleaner. It has a very distinctive, terrible smell. It burns, sort of burns at your nostrils. So be careful handling that stuff. And then sodium bicarbonate is a fun one. This is baking soda. Baking soda. And the soda part refers to the sodium in that. And so we add it to cakes. The carbon dioxide that it forms is responsible for adding the air pockets in your foods to cause the rise of a bit of your bread and things like that. Although actually breads are usually risen by bacteria action, by yeast. And then potassium sulfite is something that's added as a preservative. Preservative. I think that's right. Okay. And so that's bases. So I'm going to do a real quick little look at this next section about the formulas for acids and bases, as we've kind of introduced the concept of the base, and we're going to step forward and talk a little bit about their formulas. So almost all acids have a formula that starts with a hydrogen, or in occasional cases ends with a hydrogen. So for example, you might have HCl, which is called hydrochloric acid. You might have H2SO4, which is sulfuric acid. Or in some cases, especially what we call organic acids, you might have something like this, CH3COOH. And this is a very peculiar formula, or a peculiar way of writing this formula that has to be, that is very common and typically not done in any different ways. So although there are two oxygens here and you might be tempted to put them together, we typically don't, to try to emphasize that this hydrogen is all out by itself and is acidic. So this is acetic acid. Sometimes students remember as choo-choo, as like the train. So CHCOOH. So choo-choo is how I always remember it. It's the choo-choo acid, acetic acid. Most bases, on the other hand, will end with OH. There are a few that don't, such as those ending with carbonate, or the hydrogen carbonate ions, or ammonia. And so we see those above. I'm just going to sort of direct our eyes up here. So let's just go look back at these ones. So here we see the OH, we see the OH, we see the OH, see the OH. Even here we see OH, even though it has ammonia. And then we see those CO3 ones. So here's the CO3, and then we have one example here of SO3, and that's a very peculiar type of base indeed. Now, ammonia is an interesting one. Ammonia is NH3, and notice that it doesn't have a hydroxide, doesn't have anything, but when you react ammonia with water, the reaction that it produces NH4 plus OH, which is also represented as NH4OH. And that is, if we see above, that is the ammonium hydroxide. So when you find ammonia, ammonia is typically a gas, and ammonia, when added to water, produces ammonium hydroxide. So sometimes we see these two terms interchanged a little bit, but otherwise, yeah. Okay, and so I think we'll get into the function of acids and bases in the next video. So I'm going to leave us there at this point, and we'll have a little discussion about the function in our next video. So talk to you then.